Okay, so you're prepping for a senior software engineer interview.
Yeah.
And let's be real. It's not just about cranking out code anymore, right?
Absolutely.
It's like showing you can think on a whole other level design-wise.
Yeah.
Like really architecting elegant solutions.
Yeah, for sure. Like anyone can solve a coding puzzle.
Yeah.
But showing you can design systems that are flexible, maintainable, like well-structured, that's what screams senior level thinking, you know?
Totally. And I think you hit the nail on the head, like being able to talk about design patterns shows you're not just thinking about the code itself, but the big picture.
Exactly.
So for everyone aiming for that next big interview, we're diving deep today into one of those crucial patterns, the factory method.
Very important one.
Oh, yeah. We're going to break it down, why it matters, when to use it, and how it all works. Make it clear and something you can discuss with confidence.
For sure.
So let's set the scene. Imagine you're building a framework, right? Like something to handle a bunch of document types.
Okay.
And this framework, it needs to create document objects.
Right.
Like when a user hits new or open, something like that.
Right.
But here's the thing. The framework often deals with an abstract document class.
Yeah.
The general idea, but not the specifics, like a drawing document or text document.
Yeah, that's where it gets tricky.
Right, because you can't just create an instance of an abstract class. So how does the framework create the right type of document without getting bogged down in all the specific types?
That's a great point, and this is where the factory method really shines.
Okay, so break it down for us. What's the driving force behind this pattern?
Well, the main idea is to have a standard way to create objects and interface, but let subclasses decide exactly which class gets created.
Interesting.
So it pushes that decision of which concrete class to create from the parent class down to its subclasses.
I see.
You might also hear it called a virtual constructor, which kind of hints at how subclasses define that creation process.
Okay, that makes sense.
And it follows the open-closed principle. The application class is open for extension, like new document types, but closed for modification, meaning its core logic for creating documents stays the same.
That's super important for maintainability.
Right. Exactly.
So let's go back to our document framework example.
Yeah.
How does the factory method move that knowledge of which document subclass to create out of the main application class?
So you introduce a special method, a factory method, usually within that abstract application class.
Okay.
Often it's named something descriptive, like create document. Now it's declared in the abstract class, but its implementation isn't defined there.
Gotcha.
And then when you create specific application subclasses, like drawing application or text application, each one overrides that create document method.
Right.
And they each return their specific type of document.
I see. So drawing application returns a drawing document. Text application returns a text document. So it's like the main application knows when a document is needed, but it pushes the actual type to its subclasses through this create document factory method.
You got it. It's all about separating those concerns.
Makes total sense.
Yeah.
So the application just calls this factory method when it needs a new document.
Yeah.
Because it's calling it on a concrete subclass, it ends up with the right document type without even knowing about all the possible subclasses.
Perfect. That's exactly how it works.
So that's great for frameworks. But let's talk about our own projects. When would we reach for the factory method outside of that framework world?
Yeah.
Especially when we're aiming for that senior level design quality.
So there are a few key scenarios where it really shines.
Okay, let's hear them.
First off, if you have a class that just can't know what kind of objects it needs to create at compile time, maybe the type depends on something external, like user input, a configuration file, or some condition that only exists at runtime.
So it's about building in that flexibility and avoiding baking specific object creations into a class, right?
Absolutely. You want to keep things dynamic.
Got it.
Second scenario, it's super useful when you want subclasses to be in charge of choosing what gets created. This lets you customize and extend how objects are created in a well-defined way.
Like our document example. Different app types naturally create different doc types.
Exactly. It aligns the creation with the subclass's context.
Nice.
And the third one, this is really valuable, is when a class delegates tasks to a bunch of helper subclasses.
Okay.
The factory method can be the central point for knowing which helper to use.
Interesting.
This keeps the main class clean, less coupled to those helpers, easier to understand and maintain.
Like if you see tons of if-else statements about what object to create, the factory method could really centralize that.
For sure. It helps you manage that complexity.
So let's talk vocabulary. What are the core parts of this pattern, the terms we should know for interviews?
Okay, so we've got four main players. The first one is the product. This is an interface or an abstract class that defines the common type of object the factory will create.
Like in our example, the document is the product.
Precisely. Think of it as the contract for all those specific document types.
Got it. So it's the interface that all the products will implement.
Yep. Then we have the concrete product. These are the actual implementations. So drawing document and text document would be concrete products. Each implements the document interface with its own behavior and data.
Makes sense. What's next?
Next up is the creator. This is the class that declares the factory method. It can be abstract or concrete.
Right.
And it might even provide a default implementation for the factory method, though it's often abstract.
Right.
The application in our example is the creator. The creator might use the factory method itself to create product objects for its own tasks.
So the creator might be the one using the factory internally too.
Exactly. And finally, we have the concrete creator. This is a subclass of the creator that overrides the factory method to return a specific concrete product.
Okay, so like drawing application is a concrete creator, and its created document method returns a drawing document.
Perfect. And text application is another concrete creator returning a text document.
So to put it simply, the creator knows it needs to create a product, but the concrete creator is the one that knows which concrete product to actually make.
Exactly. It's all about that delegation of responsibility.
Okay, so we've got the what and the how. Now let's get to the why. What are the major advantages of using the factory method? Like, what are the overall benefits for the system?
One of the biggest wins, and something interviewers love to hear about, is that it avoids hard-coding those application-specific classes into your more general code.
Okay, I like where this is going.
So your application, as the creator, interacts only with the abstract document interface.
Right.
This decoupling means it can work with any document subclass you create later without touching the application itself.
Yeah, that sounds like a huge win for flexibility and maintainability.
Absolutely. It's all about making your system resilient and adaptable.
Especially as requirements change,
Exactly. Another big advantage is it gives subclasses what we can call hooks for extension. Yeah, because you can override that object creation logic subclasses can provide specialized versions of those objects.
Like that file dialog example you mentioned earlier.
Yeah. Imagine the abstract document has a factory method called createFileDialog. It might give you a basic open save dialog. Now, say you have a special document subclass for some scientific data format. It might need a custom dialog with extra options or validation rules. By overriding createFileDialog, this subclass provides its own dialog without touching the core logic in the base classes.
So it's a way to neatly extend the functionality in a very specific way.
Precisely, without messing with the system stability.
I like it. And you mentioned something earlier about parallel class hierarchies. That sounds like a more complex design topic.
It is. It's about having two sets of related classes and wanting instances from each set to correspond to each other naturally.
Okay, can you give us an example?
So imagine you're building a UI. You have graphical figure classes, line, circle, text, and so on. And for each figure, you need a manipulator object to handle user actions, like resizing, dragging, or editing.
Right, so you might have line manipulator, circle manipulator, and text manipulator.
Exactly. They mirror the figure hierarchy. Now, the base figure class can define a create manipulator factory method. Each concrete subclass overrides this to return its corresponding manipulator. So if you're working with a line, calling create manipulator gives you a line manipulator.
Ah, I see. So it knows exactly how to handle interactions for a line.
Right. This neatly ties those classes together and keeps that knowledge of which manipulator goes with which figure localized.
It makes for a much cleaner design.
For sure. It's all about managing dependencies effectively.
Okay, so we've talked a lot about the upsides. Are there any downsides to using the factory method? Anything to be aware of?
Yeah, there's a potential drawback to keep in mind for interviews. Sometimes clients might need to subclass the creator just to get a specific concrete product. If subclassing is already part of your design, it's fine. But if not, it can add another layer of classes for clients to deal with, which could complicate things a bit.
So it's a trade-off between flexibility and potential complexity.
Exactly. You need to weigh those benefits against the potential increase in complexity for your specific problem.
Makes sense. So let's talk implementation. Are there different ways to put this pattern into action?
Yep, there are a couple of common approaches. One way is to define the creator class as abstract and its factory method as an abstract method too.
Okay.
This forces every subclass to implement the factory method because the abstract creator doesn't have a sensible default.
Right. It's like saying the base class knows what to create, but not how to create it.
Exactly. This is often the way to go when the parent has no clue about the concrete product types needed. Like our application and document example, the base application usually wouldn't know all the specific document types an app might need.
Got it.
Another way is to have a concrete creator with a default factory method implementation. Subclasses can then override this if they need a different product. This provides flexibility while still having a baseline.
Interesting. So sometimes you might have a default and sometimes you don't.
Right. It depends on the specific situation.
What about when you need to create different kinds of products based on some input? Can the factory method handle that?
Absolutely. You can use what's called a parameterized factory method.
Okay, tell me more.
So the factory method takes a parameter that tells it what type of product to create.
Ah, I see.
All the products still follow the product interface, but the parameter lets you dynamically choose which one to make at runtime.
That sounds powerful.
It is. Think about our document application again. Instead of separate methods like create a drawing document and create text document, you'd have one create document that takes a parameter, maybe an enum or a string. Based on that parameter, the method decides whether to return a text document, drawing document, or another type. The UniDraw framework uses this when reconstructing objects from storage. It reads a class identifier and then uses a parameterized factory method to create the right object.
So you're consolidating the creation logic for multiple products into one method driven by a parameter.
Exactly. And by overriding this parameterized method in a concrete creator, you can still extend or change what gets created.
That's really flexible.
It is. Now, are you ready for some language-specific tips?
Oh, yeah, for sure. Especially since we're talking about interviews.
Okay, so in Smalltalk, a common technique is to have a method that just returns the class of the object to be created.
Interesting.
The creator then uses this class to make the new instance. Concrete creators just override this class returning method. It's very late binding of the product type.
Makes sense.
You can even store the class to be created in the class variable for even more flexibility without always subclassing.
Okay.
Now, in C++, factory methods are usually virtual functions. And in abstract creators, they're often pure virtual forcing subclasses to implement them. One thing to be super careful about is calling a virtual factory method from the creator's constructor.
Oh, yeah. Why is that?
Well, the concrete creator might not be fully constructed yet when the base class constructor is running.
Ah, I see.
So calling a virtual function like the factory method can cause problems.
Got it. So you need to be careful about the order of construction.
Exactly. A good way to handle this in C++ is lazy initialization.
Okay, remind me how that works.
Instead of creating the product in the constructor, you initialize a pointer to it as null.
Right.
Then you have a method like getProduct that checks if the product exists. If not, it calls the factory method, maybe called createProduct, creates the instance, and stores it in the pointer.
Oh, that makes sense. So you create the object only when it's actually needed.
Exactly. This makes sure the concrete creator is fully ready.
And you mentioned templates earlier. How do those fit in?
Oh yeah, in C++, templates can sometimes help you avoid making a ton of subclasses for the creator.
Okay.
You can have a template subclass of creator that's parameterized by the product class you want.
I see.
So you basically specify the concrete product when you use the template without writing a whole new concrete creator class each time.
It's a more general and concise way to make concrete creators for different products.
Exactly. Less repetition. And finally, no matter what language you're using, good naming conventions are key. For example, some frameworks use names like domakeClass, where class is the product type.
So it's crystal clear what that method does.
Exactly. It's all about readability.
Okay, so let's talk about that maze game example I've heard. That's a classic way to illustrate the factory method.
It is. So imagine a maze game class that builds mazes. A simple version might directly create concrete maze, room, wall, and door objects in its main createMaze method.
Okay, so every maze would be made of the same basic components.
Right. Now, what if you want different kinds of mazes? Like a bombed maze game with exploding walls, or a enchanted maze game with magic rooms and doors.
I see where you're going with this.
With the simple approach, you'd need to change createMaze to handle all those variations, which could get messy fast. The factory method solves this beautifully.
Okay, how so?
The maze game introduces factory methods for each component. Make maze, make room, make wall, make door.
Got it.
In the base maze game, they'd have default implementations that return the basic components.
So create maze would call these factory methods instead of using new directly.
Exactly. Now, if you want a bombed maze game, use subclass maze game and override make wall and make room.
I see.
Your make wall would return a bombed wall and make room a room with bomb. The original create maze doesn't change at all. It just uses those new factory methods.
That's so cool. You customize the creation without touching the core algorithm.
Right. And you can do the same for enchanted maze game, override make room and make door to return enchanted room and door needing spell object.
So maze game defines the process, but lets subclasses choose the specific building blocks.
Exactly. It's a great example of that delegation of responsibility.
Awesome. So this pattern isn't just theoretical, it's actually used in real-world systems, right?
Oh yeah, big time. Factory methods are everywhere, especially in frameworks. Like our document processing example is a classic. You'll find variations in MACAP ET++. The figure and manipulator example is from Unidraw. And even in the Smalltalk 80 MVC framework, it uses a similar concept.
Wow, so it's really fundamental.
It is. You'll also find it in middleware systems like Orbix. It's a truly widely used pattern.
Okay, before we wrap up, how does the factory method relate to some other common design patterns, like things we might see in an interview?
Great question. So it has some interesting connections. For instance, the abstract factory pattern, which deals with creating families of related objects, is often implemented using factory methods.
Right, because abstract factory is about making a set of objects, and factory methods can create each one within that set.
Exactly. They work well together.
What about template method?
Another good one. In our maze game, create maze is kind of like a template method defining the steps, but it relies on those factory methods to make the specific objects.
Okay, so they often go hand in hand.
They do. And then there's prototype, which is about cloning existing objects to make new ones.
Right.
It's different from factory method, which defines how to create from scratch. Prototype doesn't usually involve subclassing a creator, but it might need an initialized step on the cloned product.
So they both handle object creation, but in different ways.
Exactly. Different tools for different jobs.
Okay, awesome.
Yeah.
So for our listeners getting ready for their interviews, what are the key takeaways about the factory method?
The main thing to remember is it provides a really flexible way to make objects by defining a standard interface for creation, but letting subclasses decide the actual type. This keeps your code decoupled, makes it more extensible and easier to maintain over time. By delegating that choice to subclasses, the factory method lets them customize things, and it's great for managing those parallel class hierarchies.
And for senior software engineer role, being able to explain all this, showing you understand the benefits and trade-offs and talking about real-world examples, that really demonstrates a deep understanding of design principles.
Absolutely. It shows you're thinking about the long-term building systems that are robust, adaptable, and well-organized.
So as you're thinking about your past projects and future designs, really consider this. How could using the factory method make your code more maintainable and flexible? Have you run into situations where this pattern would have been the perfect solution? It's something worth thinking about. Thanks for joining us on this deep dive today.